Hello and welcome to another LeetCode video. Today we're going to be looking at another question from the LeetCode interview 150. That would be LeetCode 121, which is best time to buy and sell a stock. This falls under the category of array problems. It does also mention dynamic programming. However, utilizing dynamic programming for this problem would probably introduce unnecessary complexity. So we could look at more of a greedy approach. But just to go over the problem description, we're given an array of prices and we want to find the price of a given stock on a certain day. So in our array, each number is going to represent a day. We're going to start at day one. And essentially what we want to do, just like anytime you deal with stocks, you want to buy low and sell high. So we want to maximize our profit. We're going to choose a single day to buy one stock, and then we're going to choose another day in the future to sell that stock. So if we can't achieve any profit, then we're going to return 0. And so let's go ahead and look at draw.io, and we can see our array here, our example array. This is the same example that LeetCode provides. But in this case, we could start on day one, just to kind of walk through describing how this problem works. This also would be good to do in an interview, but we would start on this day, and this would be our minimum. We would start here and we would proceed to look at the next. This would represent day 2. This would be day 3. So based on this, we can see as we move along in this array, this would be our profit would be 0. And there's two things we want to track. We want to track profit, and we want to track the minimum price or the lowest price that we've seen. So in this case, our minimum price is going to be 7. Whoops. It's going to be 7. And as we go along, we're actually going to write some logic to check to see if we've seen a number that's lower than our current minimum so that we can set minimum to the lowest value. So if we move forward in our for loop, we would actually set our minimum to 1. So if I can just change the color here, in this case, we would say, hey, we don't want 7 anymore. We want to set it to 1. And throughout the entire iteration of this array, it would stay at 1. Essentially, it would stay at the lowest price that we could buy the stock at. And then for profit, once we get to 6 here, we can see that ideally we would want to sell it on this day here when the stock is at 6. We would sell here, which if we subtract 6 minus 1 equals 5, that would be our profit. And that's exactly what we would return. We would return 5. Now, of course, if for whatever reason we didn't see this 1 here, let's say that the stock price went up and all these numbers here were lower than our minimum, which in this case would be 9, we would return 0 because we wouldn't see any profit whatsoever. So probably good to walk through that in an interview, and then mention, if you've never seen this before or have no idea how to solve it, you could mention a brute force. There's 2 solutions we're going to look at. We're going to look first at brute force. So one solution would be brute force. And this would involve a for loop where we would loop we can just say, writing some pseudocode, we can say for, and then j, we're going to say +1 because we just want it to be basically start the day after or the second day. And here we would just say, get our profit, prices j minus I. This is a brute force. You could go about describing this. The downside, of course, is that this is O of n squared for our time complexity. And our memory would be constant. So we can do a bit better. And as we described previously, we can look at a greedy approach where we would do a single pass through the array. And all we would need to do is we could do a pass through the array, keeping track of our profit, our minimum, and as we go through, we would set our minimum to the lowest value, which would tell us when to buy. And then we would calculate our profit as we move. We would calculate the profit as we move to each item. And this would tell us when to sell. And that would give us ultimately a time complexity of a linear time complexity. And for memory, we would have the same. This is the good news. We actually would have still a constant memory consumption or complexity, because in this case, we're only using two variables. We're not using a hash map or anything fancy like that. So let's go ahead and see what this would look like. We've got our max profit. We're passing in prices. We want to keep track of first profit, which our profit is 0. And then min is going to be, we're going to start at the minimum value, which would be the first item. We could also set this to some large number. It doesn't really matter what we set it to, because we're going to go ahead and we're going to set it to the lowest value. So from here, we could say I equals 1, because we are going to start on day 2. Day 1, we are basically just setting our minimum. And then we really care about day 2 to see if the price is lower, to indicate whether or not we want to buy. So we're going to say while I is less than prices.length. We're going to iterate I. We're going to increment I, and then here is this is basically going to tell us when to buy. And what we're going to do is we're going to say if minimum is greater than prices I. Oops, we got a bug. I put I here, but really should be our first item. Okay, so if our minimum is greater than whatever price we see, then that means that we are essentially seeing a lower price, and we want to say our minimum equals that price. Which is really just saying, hey, let's buy this. It's an optimal time to buy. And then here we're going to go ahead and look at when to sell. And we just simply say prices I minus min, if min minus price I is greater than profit. Let's see. Then we want to say our profit equals prices I minus min. So we've got 4. Let's go ahead and let's see, what is it not happy about? Expected. We'll say we're going to return profit. And let's just go ahead and get this ready to run. Max profit. We're going to get our sample input. And now we're going to see, let's take a look and see what's going on here? So we've got our loop for, oh, I see. Okay, so we want to say if, and so in this case, based on what we discussed, we are starting with a minimum of 7. We start at day 2, which is 1, we buy, and then ideally we want to sell on the day when the stock is at 6, which would give us a profit of 5. So let's see if that's what we got. So it does return a profit of 5. And let's just go ahead and see what a case would look like. So let's say it goes to 9. If we do buy at that price, which we wouldn't, it would set it to 3. We would actually end up buying at 3 and still selling at 6. I'm sorry. We would, let's see. So let's say that we buy at 9. So here's a case where we should actually receive a, oh, whoops, forgot to save. Okay, so here we would see 9. Oh, all right, let me fix this. So we've got if. So from here, really what I want to say is if we buy at 9, then this actually should return a 3. Oh yeah, okay. It's because our minimum is set to 3, which is the lowest price that we see, and then we sell at 6, which is a profit of 3. But really what I want to show real quickly is the instance where we buy, let's say that we start at 7, we see a 5, and then from every day forward, it just goes down. Which would mean we would basically hold, we wouldn't sell. And in that case, we would see a 0. So that's pretty much it. This is an easy LeetCode, just another good question to know, and thanks a lot for joining.